DE certification. Okay, these things basically involves the terminologies and all these things. Like I can say, Spark cluster-based aspects. So because some of the terms are very new for us. Okay, so maybe technically we are implementing the task with RDD and data frames. Um, but the point here is 17 some sort of some kind of aspects they are asking in clustering also. Okay, so I thought of maybe giving some insights into that, which really helps us to maintain the convention. So out of those is a generic way of defining the terms and all those things. Now, as far as this Spark is concerned, okay, we are having certain terms like executors and as well as the slots, tasks, jobs, and stages. Okay, likewise, we are making use of some of the things, and in parallel to that, we are having the cluster manager also. I'll try to connect the dots and with some set of the statements where we can try to understand how these Spark executors and slots, tasks, or jobs are relevant to this cluster manager and how we are executing these kind of the tasks. Uh, Coming to the executors, so basically, friends, here there is a analogy like like we're having some Spark session, or else we can see that as a Spark context. We pretty know that this is the from 2 or 3 version of the Spark we are getting this, and in the initial versions we're having only the Spark context. But with the Spark context explicitly, I need to specify the Hive context and SQL context. Whenever there is a requirement, then I have to specify explicitly that we have seen earlier. But
Mhm.
now, in case of the Spark session, they are inbuilt friends. Like if I am saying Spark session by default, I can make use of the Spark context, and of course, it helps us to maintain the Hive context, and it is also giving us the SQL context. So this is the one where we can perform the activities in all the 3 ways.
Uh,
Now the
sorry,
point is,
just want to know.
yeah,
Okay, like with the Spark session, like we can use Spark context, and like can we use
uh,
separately as well? Like after Spark session, can we use
uh,
separately like combination Spark session plus Hive context or Spark session plus SQL context? Can we use separately as well?
yeah, Himanshu, because see here we are having a term Spark here. Spark generally how we'll define Spark session dot. Okay, so and here we are going to build app name
Yes.
like that. We'll be dealing now.
Yes.
Similarly, we are having the Spark context also. Okay, so how we'll do is Spark dot Spark context. Hope you got the point. Now, this particular object is referencing Spark context, Hive context. Whenever there is a requirement, you can directly maintain that. And
Okay.
SQL context. Okay, na? But whereas in the earlier cases, see, I cannot directly use the Spark context within Hive context and as well as the SQL context because the Spark session by default containing these three. Whenever there is a requirement, you can directly access them. But Spark
Okay.
context is not having the access of the other things. Like I need to explicitly mention Hive context again. There is a separate option. And SQL context also I cannot get with the Spark context. Hope you got the point.
Yes. Yes.
Okay, no?
Yes. Yes.
Whereas in Spark session, I can able to get the benefits of the Spark context, Hive context, and as well as the SQL context. Okay. So, and moreover, in the questions also, you may get this way. I am running Spark 3, for example, and if I want to run through Hive context and as well as the SQL context, then what is the best option? Maybe they can give Spark context, Spark session, and some other aspects. But of course, obviously, the answer is Spark session only because from 2.x and 3.x, we are mostly using the Spark session. We are making use of the Spark session. And moreover, along with the Spark context, if I want to scope the Hive and SQL context, in that particular case also, the best option is the Spark session. You may ask this question, but why we need to scope the Spark context? We can directly go with the Spark session. Na? Then why again we are talking about the Spark context? The reason is pretty simple, guys. Now still some companies are using this 1.x only, and they are pretty happy with RDD orientation and all, and they are very rarely using the SQL or Hive context. So in that particular case, better you go with the Spark context. Reason is we are pretty clear about okay, this thing is only related to the RDD orientation, and we are happy with that convention. We are not using any advancements. We are not at all bothering about the Hive context or SQL context. Some projects would be there, friends. Suppose if you consider the maintenance project, maybe the space issues or performance issues would be there with that. Then in that particular case, hardly what we'll do is partitioning and as well as the garbage collection change, all these things we'll be doing. So in that case, we can make use of the Spark context because this is the most of the times the memory based kind of the aspects are there with respect to the Spark context. Okay, and one by one we'll see how these particular things are communicated and how partitions helps us and garbage collectors, all those kind of the aspects. Most important point is the Spark driver. Okay, as a developers, we need to start the program somewhere, and in Java we can name that as a main function, and in Python there is no main function or such kind of things. But still, we can explicitly mention the function definition and calling of the function. So this Spark driver is a typical component, okay, which is generally executes. Okay, so and of course, the Spark driver in this way, there are certain executors, okay, which are running the code, and there is a standard statement, friends. Just these executors accept the tasks, okay, because the Spark driver is having some kind of the tasks from the Spark driver, okay, from the Spark driver, and then execute the same, executes the tasks, and most importantly, guys, and returns the appropriate outcome, returns the results or outcome to the driver. Have a look on this, guys. Now, what it does is just in a simple analogy, Spark driver, and we're having certain executors, executor one, executor two, like that. I'm having some set of the machines. What it does is the task is given to the executor by the Spark driver, and it executes the appropriate task, executes the task. And the first important thing is submission of the task, the execution of the task, and getting the result, a result of the task, okay, is written back to the Spark driver. And here, friends, to confuse us, some of the options maybe they can give like this. Spark driver give the task to the cluster manager, and executor execute the task and submit the results to the cluster manager. Cluster manager is not responsible for getting the results and submission of the task, friends. Be cautious about that because multiple times we are getting this question in the earlier papers we have seen, like Spark driver and executors are tightly coupled. So just it is going to assign the task, and of course the executor is going to execute the task, and finally the results are given back to the driver. Okay. So and moreover, can you give me the difference between Spark and Spark driver? So generally, friends, here is a process actually. Is a process, and is a Spark is a cluster manager actually, is a framework fundamentally, and what it does is it generates. Okay, just it generates very important thing, friends, logical and physical plans on the driver, because there are certain optimization techniques available. To name a few, adaptive query execution, dynamic pruning techniques. Okay, these two are most frequently used kind of the optimizations. Okay, probably in the today's session only, we'll talk about these optimizations. So as to achieve these kind of the optimizations for the better performance of the querying, the Spark, what it does is it generates the logical and physical plans on the driver. Just it is making use of Spark driver. On top of the Spark driver, it is going to execute the logical and physical plans, because one of the important aspect is that even in our case also, suppose if you want to release, or if you are eager, if you are asked to release the product by this weekend by the client, then accordingly you have to plan. So how many tasks are there to execute, and how many team members are there, and how we are going to distribute the work, and then tomorrow again a stand-up call, okay, all the updations and a print kind of the meeting. All these aspects, how we are planning. Okay, logically you have to plan, and exactly the appropriate mapping should be there. So similar to this kind of thing, Spark also having some logical and as well as the physical plans which are running on top of the Spark driver. Okay. So the summary is pretty simple, friends. Yeah, yeah, go ahead.
Yeah, just want to know one thing over here. Okay, so all these things are being done by Spark Driver. Like
Uh,
Driver only help for the optimizing. So what's the role of the uh, cluster manager over here? Do we
yeah,
have?
yeah. So because what I'm doing here is, guys, first I'm separating the Spark driver and cluster manager, because cluster manager is a kind of the component which is helping to reserve the space. That's all. And moreover, I'll talk that thing in a while,
Okay,
Himanshu,
okay.
because now, however, your doubt is leading to that cluster manager. That's what I required actually. Okay, so there is a strong connection between these kind of things. Okay. Now,
Mhm.
in the Spark execution hierarchy, guys, we pretty know that there are jobs, there are stages, and then we are having the tasks. And one time they asked the question, what is the smallest component of the appropriate process in the Spark? These are all the tasks. The highest hierarchy is the jobs, and these jobs are combined into the stages. And finally, we are getting the tasks as the smallest component. Now, one of the important thing, guys, here we need to observe. Of course, job in the sense, see here, a Spark driver, okay, which is having some set of the jobs. These jobs need to be executed by executors actually. This thing we know. Now, at the time of evolving or logical or physical planning of this particular job, what it does is that you might be knowing about this thing, friends, narrow dependencies.
Mhm.
Okay, narrow dependencies in the sense, just
It's
I'm
like
having
filtering the
is
data.
a no shuffle kind of thing. Like,
Mhm.
narrow transformations, wide transformation kind of thing. And
Yeah.
here, narrow dependencies, there is no much kind of the shuffles or comparisons among the appropriate partitions. Now, in this particular case, what this job is doing is all these particular tasks, maybe job one is having task one, task two, three, and four. Out of those things, T1 and T3 are the narrow dependencies. Assume that these two are having a narrow dependency. What it is doing is it is establishing stage one, and it is combining these tasks into one stage. Whereas T2 and T4, some other narrow dependency, just it is combining them into some other stage too. Likewise, what it is doing is it is packing the appropriate tasks based on the dependencies. So now, after submission of this particular job and a logical as a part of the logical and physical plan, it is going to segregate the tasks, and those particular tasks are grouped into a stage actually. So now you can, they may be asking like this: in a stage, can we get shuffle? Okay, no, because in a stage, it is performing is a stage containing only narrow dependent tasks. Okay. Now, if I'm talking about that stage is no more relevant to the wide or shuffling kind of thing. The stage is purely containing some kind of the task. Accordingly, it is going to perform the activities. Okay. And these tasks are unit of work done per partition, slots, and of course, help this part to parallelize the work. And some more options I am introducing, friends. Okay. So, as said earlier, this is the unit of work done, okay, per partition. And moreover, there is a important point, friends. Slots are nothing but every execution needs some memory, actually some allocation, na? So this particular slots helps Spark engine to parallelize the work, now you observe, guys, here. Suppose I'm having task 1, I'm having slot 1, slot 2, and slot 3. What they are doing is these particular jobs, whatever the job I'm having, split into the multiple tasks, and all these particular tasks are running parallel. One important point is how Spark is achieving the parallelism is with the help of the slots. With the help of the slots. Now, the partition we know, friends. Like a partition is a kind of thing where, suppose if I'm talking about the narrow partition, narrow transformations or narrow dependency kind of thing, what they're doing, friends, here, just to observe, I'm having partition 1, partition 2. Accordingly, I'm having some corresponding tasks. This is the task 1 and task 2. And if there is no shuffling in the task, then we are naming those kind of the transformations are narrow transformation. Just we are making use of that thing. Whereas if there is another thing, like I'm having partition 1, 2, 3, and of course I'm having the corresponding task 1 and task 2, maybe filter or reduce by key or whichever. So in that particular case, what they do is they are going to shuffle the appropriate data. Okay, because a single partition is not enough to get the appropriate result. So in that case, even in sorting also, comparisons and as well as the shuffle is going to happen. So these kind of transformations are known as the white transformations. Okay, your partitions are mapped to the corresponding tasks. If these tasks are running one to one, then they are all narrow transformations. There is no need of shuffle, or there is no need of comparing the appropriate partitions with another partition. But whereas in case of the wide transformations, we need to compare and we have to shuffle and we have to perform some kind of the wider range of the activities. And moreover, now you may ask this question: what is the relation between the executor, because executor is a machine, and slots? Okay, executors and as well as the slots. Generally, guys, the slots, as mentioned earlier, there are placeholders where it provides some kind of the memory so as to execute the appropriate tasks. In general, guys, there is no restriction on the number of slots, because if I'm taking some Cloudera AWS client of the cluster, maybe with 100 nodes, and each and every node is providing us some sort of the memory slots. Okay. So executor can have multiple slots. I mean to say, suppose I am having a kind of the machine, and that particular machine can be considered as the executor. And here, as per the current status, we are having three slots. Assume that this is executor one. Similarly, we are having executor two. Maybe there is a possibility of having S4, S5, S6, 7, 8. Okay, here I am having three slots. Here I am having five slots. Okay, so what it is allowing us is the executor can have multiple slots as per the configuration of the machine. Maybe if you are running AWS also, we are getting the dynamic allocation of these executors, and accordingly, the executor is having some number of slots, which enables it to process multiple tasks in parallel. Suppose executor one is getting task one and task two scheduling. Executor 3 is getting T3. Any doubt? T3, T4, T5, these tasks. So actually, friends, these particular slots are the memory holders. Okay, where these are trying to execute the appropriate task in parallel. Now, just observe here, guys. If you are getting any questions from the slots, remember the word parallel. Okay, so parallelism is the main aspect where you can achieve with the notion of the corresponding slot and as well as the executor. Okay, hope it is clear with you guys. Okay. Now, as our friend asked, then what is the role of the cluster manager? Okay, so the second aspect, first aspect so far we have seen the driver and as well as all these executors and then logical and physical plans. The Spark can run on top of the Spark driver. And again, the Spark driver is having some job. And as the next thing, we are having the stages and all the tasks which are not having any wider dependencies can be clubbed into a single stage, and a task is a lower hierarchy, okay, where that is the smallest unit of the work done. And related to this particular task, we are having another term called slots. Due to this particular slots only, the executors are getting the parallelism. Okay, right. Now the point is, then what is the which are all the activities done by the cluster manager? Let us see this. Because many a times, guys, we are in a dilemma of what exactly this part driver is doing and cluster manager is doing. Simple thing. Basically, the cluster manager, just have a look on this, guys. Cluster manager allocates resources. So just it is going to allocate the resources to Spark applications, to Spark applications, and maintains the, okay, one more thing is, and maintains the executor processes in client mode. See here, guys, because I intentionally get this mode of execution because there are a lot of confusions in client mode, cluster mode, and local mode. I will clarify in a while. Now we are talking about the client mode of execution. Assume that. So what exactly the cluster manager activity? Allocation of the resources to Spark applications. It is not saying Spark session or Spark context or Spark driver. Because friends, here the Spark application, the entry point is Spark session or Spark context. Again, that particular Spark session is having some main method. It is nothing but the Spark driver actually. So far, we have seen the Spark driver. And one of the important aspect is now onwards, if you are talking about your Spark session or Spark context, one thing you have to remember, Spark context is strictly helping you to handle the situations of 1.x kind of thing. Purely it is relevant to the RDD orientation and all. Whereas if your application demands the use of both Hive context and as well as the SQL context, better you go with the Spark session. So that is the context. But whereas in Spark driver, if you are dealing with the Spark driver, whenever someone asks you about the Spark driver, They are expecting you to talk about the allocation, execution, something like job and stages and thereafter the task. The main functionality of the Spark driver is just it is going to communicate with the executor, and that executor is having some set of the slots, and this Spark driver submit the task to the executor, and those tasks were executed by the executor, and finally the results are sent back to the Spark driver only. Hope I'm clear with you guys, because here cluster manager activity is only allocation of the resources to the Spark application and maintain the executor process in the client mode. Executor process maintenance in the sense how many tasks are there, and whether these executors are enough or not, all these kind of things. And moreover, you may ask me this question, and then what about the cluster mode? Okay, in the cluster mode, basically, guys, the cluster manager can be operated in three modes actually. As I said earlier, client mode is one thing, and thereafter we are having another option. Now I'm talking about the cluster mode, and we're having one more mode called local mode actually. Local mode. Let me talk each and everything, so that in a while definitely we'll be getting the clarity about client mode, cluster mode, and local mode. Okay, don't get confused with client mode and local mode, friends. Sometimes people may feel that client mode and local mode are same. No, no, no. They are different. Now I'll clarify that how these cluster mode, client mode, and local mode differ. In terms of cluster mode, okay, so just the cluster manager, whatever the cluster manager we are talking, okay, is located. See here, guys, how it is operating is located on a node. On a node means the machine actually on a node. Okay, other than the, see here, other than the client machine. Client machine is something like where you are submitting your job. Okay, however you are going to submit your job now. So to submit that particular job, maybe I can select multiple modes, my cluster mode, client mode, or local mode. Okay, so if you remember, friends, just we have seen some master as an. Sometimes this is local, sometimes this is Spark. Like that we have seen. So I mean, if you are having your local machine, okay, and clearly you can use that. Or else if you are submitting your job in the client mode, but within that client mode, you may be having either add or your Spark, or sometimes maybe Mesos, any of the cluster managers. But whereas if you are running, to make sure, one example, I'm having AWS cluster, okay, which is with some Cloudera uh, nodes, okay, Cloudera manager kind of thing. And here I am having, assume that I am having support of Hadoop distributed file system, and Hive is also configured, and they have configured Spark. And this Spark can be executed in either the Scala mode or in Python mode. We are not interested in R or something like that. Only we are happy with PySpark orientation. Now, just while submitting this particular job, just have a look on this case. How do I submit job is Spark submit. Okay, master. Maybe you can say your master as add, your master as add, and here you can specify the client. From the client I am submitting. Okay, and your deploy mode, I want to deploy in the client, and then you specify whatever the file you are having. Maybe I'm having the file name as mapred1.py. Maybe some of the data friends, whatever the source file you are having. Now it's here itself. You can clearly see that this is the cluster manager ARM.
Mm-hmm.
So that means your cluster manager may be run in master mode. Okay, or else you can run in the client mode, or else though you are specifying client, it is activating in the cluster mode only. So that's what I'm talking about here. If you see in the cluster mode, Okay, in the cluster node, the cluster manager is located in a node other than the client machine. Assume that this is my machine, and Himanshu and other guys, Purna, are having some of their own machines, and we are all accessing one AWS cluster. Assume that from India, we got this access of the AWS cluster, so that we are submitting our job. Now the point is, if you are running in the cluster mode, make sure that the cluster manager won't be in your local machine, guys, because it is located on the node where your AWS cluster or Cloudera got configured. And from that, okay, just the cluster manager is going and executing the task. That means from there means, okay, now from other machine, okay, from other machine, uh, it starts, okay, just it is going to start and ends executor process on the cluster nodes wherever there is a requirement as required. So, and as required by the Spark application, of course, this is understood as required by the Spark application. See here, one more point, running on the Spark driver. So, pictorially, what I'm doing here is just observe here, guys, and we are submitting Spark application, and this is having the Spark driver, and we are submitting our job from the client in a command mode. And this submission reaches to other machine. Okay, this is machine one. Assume that this is another machine two. I am talking about the cluster mode, guys. In the cluster mode, how this cluster manager is activating in the cluster mode. So what it does is just it is launching this cluster manager, other machine it is having, and it is having the executors. The executor again having the slots, slot 1, 2, 3, 4, so as to execute the tasks. Okay, so now we'll read the statement. Okay, just have a look on this, guys. From other machine, the cluster manager starts and executor ends the executor process on the cluster nodes as required by the Spark application running on the Spark driver. Okay, so this is the machine one where we launch the appropriate submission. After reaching this particular submission to the another machine, there the cluster manager perform the activity. Okay, so that means, but now I am asking you, what about the client mode actually? Second mode is there na? In client mode. Okay, in client mode. Okay, the Spark driver, let me clarify that. The Spark driver schedules, okay, tasks on the cluster, not the cluster manager. Observe the statement. In the client mode, if you are running, probably we are not engaging the cluster manager, because the client mode, the Spark driver schedule the tasks on the cluster, okay, not the cluster manager. But the thing is, again, one more important thing is, you may ask this question, then where is the cluster manager? Cluster manager may be in the another machine, but I don't want to touch the cluster manager. And it is enough to handle my own standalone kind of the cluster. Maybe I'm running the Spark job for the sake of map or reduce by key. Only those kind of the POC kind of thing. I really not require any cluster manager. And you may ask me, then how it is going to schedule? Actually, if you refer friends, Spark itself is a framework, and it can run on the standalone mode. Okay, that is in the Spark mode. Okay, even without taking any help of the Air or Mesos or whichever the engine, it is itself, it is having that is the main key success factor behind the Spark implementation, guys. So that is the reason, even in case of the Jupyter also, okay, if I'm talking Databricks, it becomes cluster mode actually, because we are submitting our job and somewhere our cluster is there, and there we are we are submitting our job and we are running and getting the results in again our machine. So, but whereas in case of the Jupyter notebook, you can configure your Spark engine, guys. So in that particular case, it purely belongs to the standalone kind of thing, because here itself I'm configuring my Spark installation, pip install some PySpark or whichever. So just you can manage your activities. Now the third option is also there actually. The third option is the local mode actually. Now you tell me, guys, what is your analogy in the local mode?
Uh,
Simple point, in local mode, there is no cluster. There is no cluster at all, because
yes.
see, we don't have any option. We are only having our local machine, and we are trying to run our tasks. Even Databricks is not the local mode, guys. Just to have a look on it, because in Databricks, our community edition also, we are explicitly configuring the cluster. Does the cluster is available in our machine?
No, we don't have cluster.
No. We don't have a cluster because we are running in our machine, but though we are running from our machine, but we are requesting Databricks to allocate some cluster. If you remember and if you observe the analogy behind that.
Yes.
Okay. Yeah. So now, if you are referencing friends, can you give one single statement like difference between cluster mode versus client mode versus local mode? Because we are getting 2 to 3 questions here related to the cluster manager, Spark driver, and all. Definitely, they are asking some 2 to 3 questions. So now you observe, guys, here in cluster mode. What is your observation?
In the cluster mode, like
Uh,
cluster cluster manager will give uh,
uh,
give this like give the task
allocate the
basically. Allocate.
allocate task to the appropriate executor.
Yes, yes. In the
Uh,
client mode,
what
it
this
would be
Spark driver, however, resides in another machine actually, another machine which is contacting the cluster manager. In the client mode,
it would be direct Spark driver.
that's it. Spark driver. And of course, still cluster manager is there, friend. Don't get confused. Cluster manager is in another machine actually.
Okay.
Is in another machine. But whereas in the local mode, no cluster.
No
There is
cluster.
no cluster at all. Okay. Because Spark itself is having the flexibility of running the appropriate the task in the standalone mode without any add measures or something. Then we can make use of that kind of the convention. Now, one more thing, friends, here there are certain aspects I said, no, like dynamic partition along with the pruning technique. So this statement, uh, what exactly the dynamic partition pruning and how it is making the Spark optimized is. This is the third topic. Just we are talking. And dynamic partition pruning is intended to skip over the data that you do not need in the results of a query. See, what do you mean by pruning? Maybe from your data mining, okay, or from your data structures. Tree pruning, you would have heard about this. Pruning means avoiding the unnecessary parts, maybe in binary search or in binary search tree, maybe some sort of the data structures. There is a concept called pruning. Pruning means whatever the things I am requiring, only I am focusing on those kind of the parts and avoiding the unnecessary parts. So what this dynamic partition pruning specifies is mainly intended, okay, to skip the data, whatever the data I'm having, maybe we are working with the heavy data that you do not, okay, need in the results of the query. So generally, guys, maybe I'm running a huge job, but I practically if I'm verifying or manually if I'm verifying also, I don't know which are all the records or which are all the data items I am not requiring. But whereas the Spark providing an option called dynamic partition pruning, the name dynamic involves while running the query also. Okay, in the though you submit your query with all the possible features, with all the corresponding data, but due to the intelligent nature of this dynamic partition pruning, okay, just it is going to skip the data that whatever the data which is not requiring at the moment, then it will be cutting down as a prune kind of thing, and it is performing the activity. But one more thing is there, friends. Here, one more option. Actually, I have said like adaptive query execution. People most of the time getting confused between dynamic partition pruning and adaptive query execution. Let me clarify what exactly this adaptive query execution is. Observe here, guys. Whenever there is a re-optimization, okay. So re-optimize query plans. Okay, re-optimize the query plans based on the okay runtime statistics. That means already the query is in process, okay, collected during query execution. This is really amazing, friends, because in case of the dynamic partition pruning, while performing some shuffle or while performing some sort of the wider transformations, there may be a possibility of avoiding some of the data items and as well as the features which are not really required. Okay, that is making sense, and of course, we are not getting any surprise with that because keeping the data you do not need in the results of a query. But here you see, re-optimize query plans based on the runtime statistics. Okay, what it does is Spark with the adaptive query execution observes the appropriate statistics. Maybe running query one, we may be getting the information of the corresponding information, and based on these particular statistics, maybe how much space incurred, how many joins we are having, or else maybe how many indexes we are working on. So all these particular things can be optimized with the help of the results we got. So maybe it is analyzing all the statistical things, and thereafter it is going to suggest us some sort of or dynamically, or it is maintaining some re-optimizations related to the things. Now you may ask me, should I consider adaptive query execution or dynamic pruning? Now you see here, friends, some of the points I am mentioning as a kind of the note. In case of the dynamic, okay, partition pruning, okay, these things are pretty helpful. You can make use of this dynamic partition pruning. Works well in case of join options, or else I'm having some sort of um, some broadcast variable. Broadcast already we have seen. Okay, some sort of the broadcast variables. This actually happens in both the logical optimization as well as the physical planning stage. Okay, so both can be helped in the logical and as well as the physical planning of the data. As we have seen, Spark applies some logical and physical planning on top of the Spark driver. So there is a chance of achieving this dynamic partition pruning. And if you are referencing the advantage, okay, like if you are making use of advantage situation related to this thing, these kind of the dynamic partition pruning helpful in joins and broadcast kind of thing, and logical and physical partitions are making over with respect to those kind of things. Now, one more question we can see here, guys. So in terms of Spark versus Hadoop, though we are not having the Hadoop, especially in our syllabus of the data engineering certification, but reasonably we should know about because some of the times we are making use of the cluster ARN. Okay, so automatically ARN is uh, a cluster management technique, okay, or resource management technique, which is strongly used by your MapReduce. That's what MapReduce 2 and ARN are tagged. And MapReduce 1 and this HDFS were tagged. Okay, so now the point is in what way Spark is better than the Hadoop engine? Because always we are talking about Spark optimizations and in-memory computing and all those things. Uh, so if I'm having the storing of the data and as well as processing of the data, as Spark is okay having the capability of the in-memory computing. Okay, so in-memory computing. So obviously your storage and processing is very fast. Okay, very fast. But whereas what about the Hadoop kind of thing? So your Hadoop, friends, one of the problem with Hadoop is while running the MapReduce jobs, every time what happens is it is going to store the data, maybe temporary results or permanent results, into the this disk based actually. So you observe guys every time some job is running and there are certain results related to this particular job and they are going back to the disk and again I need to fetch the appropriate information and there are a lot of latency, context switch, all these things are there. So one simple point is in terms of the Spark, there is no disk writings or disk readings. Directly we are managing the in-memory computing. Whereas at the moment I'm talking about the Hadoop, there is a complete even temporary results should be stored in the disk only, guys. Okay, that is the main important aspect where you can refer the usage of the Spark orientation as well as the Hadoop orientation. Now, in parallel to this, we are getting some more options actually. So that is the other option, your garbage collection aspect in Spark. Now in Java, actually this entire Spark is running on top of the JVM. That's what the reason we are having the garbage collection. But there are certain questions we got friends actually in earlier things. Like this garbage collection, what it does is just whatever the objects I'm having in the memory, generally speaking. So if they are no longer used, okay, they are with the help of the compaction, okay, collecting or all the unused objects, and they will be removed from the active state, okay, or else active state. This is the analogy we know from the engineering days. Also, we studied this one. There is no surprise for us in terms of garbage collection, but in the terms of like Spark, suppose there is a question like this, guys. I'm having some RDD. I persist this particular RDD with the help of the cache. You guys pretty know about what do you mean by caching and what do you mean by persisting. Actually, this particular RDD by default is not cached, not cached. Explicitly, I can use the RDD dot cache or persist. Then it can be cached. It can be cached. What do you mean by caching is, remember one point, friends. Cache always help the most frequently accessed data will be available with the caching. Then obviously it is pretty faster. Okay, cache is pretty faster when compared with the RAM. Spark itself following the in-memory, but compared with that in-memory, we are having some more benefit with the caching. But you tell me, what is the problem with the caching, friends? What is the problem with persist?
I think caching
Problem
will
with
happen in the like hard disk kind of. So that
It is nothing but permanent storage again. At
yes,
certain point of time, we need to clear that cache. Now the
yes.
question here is, now the question I am asking you, suppose I am running a garbage collection. I am running a garbage collection. Can I remove the persisted objects or not?
We
Okay,
should.
so we should actually. So,
Yes.
making sense, friends, actually. The reason is here we are sort of some stuck here. Maybe earlier we felt that some of the RDDs are really helpful to us. So, of course, as a typical programmer or a developer, we need to do that. But
Yes.
whereas once that particular caching is done and we are done with the entire thing, now my question is if I am running or if Spark is running garbage collector, okay, will it remove the persistent of? Yes, friends, actually. Yes, of course. There is no restriction, okay, there is no restriction for the garbage collection to remove the persisted objects. Okay, and moreover, one important point, this garbage collection runs in the first come first serve, not that LRU fashion, friends, actually. Least recently used. Okay, least recently used. That means least recently used means which we have not used so far. For a very long back we have used, and so obviously the long back used objects can be removed with the help of the garbage collection. Though no matter whether you have cached or persisted, but still, okay, but still those kind of the things are definitely removed or handled by the garbage collector. Only the thing is it follows the LRU fashion. It follows the LRU fashion. So one more point I am asking you here. Suppose if I am running the garbage collection, a serialized data frame. Okay, hope you are aware of this serialized data frame versus unserialized data frame. What do you mean by this, guys?
Uh, Idea. Can you please?
In Java also, in Java also, serialization means maintaining the state of the objects. Okay, this is one thing. No state maintenance. Okay. Now the point is that suppose if I am running a garbage collection, tell me friends, which objects garbage collection take less time because already you maintain this particular state. Everything is with this object, so we are having complete narration actually.
Hmm.
So garbage collection takes less time on a serialized data frame than and the unserialized data frame because serialized caching is a strategy to increase the performance of the garbage collection. Okay, so now we are adding one more thing. This is can be known as the caching kind of thing, which is requiring okay requires less time compared with the unserialized data frame. Be cautious, guys, because here we have seen three aspects actually. One is the GC, garbage collection. Second is the caching. Third is the serializability. Okay. In a way, you can merge these two actually. In a way, you can merge these two, cache and serializability. Now, what we are saying is your GC requires less time on these kind of the things. But whereas your GC requires more time to garbage collect on the unpersisted and unserialized data frames. A very simple aspect. And this is also they are touch basing on this garbage collection kind of the things. So finally, the optimization not only with the dynamic pruning, not only with the adaptive query execution, with the optimization of the garbage collection performance, uh, but what is the problem with the? Is there any threat for caching with garbage collection, friends? Actually, what we need in the caching means what we are doing, we want to persist the data. But what GC is doing, it is unpersist. Okay, exactly the opposite kind of the convention. So if I'm optimizing my garbage collection, if I am optimizing the garbage collection performance, then what should I limit in a way? I should limit the uh, caching ability. See, this thing, guys, is a pretty strategic aspect actually. In another thing, what we're saying is that garbage collection runs very fast or requires less time when you are caching, when your objects are cached and serializable. So in second statement, what we are doing is your garbage collector requires more time when you are not serialized with the data frame. Now the conclusion is okay. What we are doing here? Suppose if I am optimizing my garbage collection, if I want to speed up the compaction, that means all the unused objects whichever are there in the memory, I want to clean up. Okay, at times, I don't want to miss out any memory location for the sake of unused objects. But if you are increasing your efforts on the garbage collection, definitely you have to limit the caching ability. That is understood, no? Okay, that is the case where you need to observe some sort of compromise of this caching and as well as the persistence. And but don't miss out the point. The garbage collection took less time if your objects are cached and serializable. But in a way, it doesn't mean that your caching will be empowered with the garbage collection. That is a different story, guys, actually. Garbage collection is purely the developer intention so as to clean up the memory and so as to utilize the memory in a efficient way. Caching is the technique provided by the Spark so as to maintain your data, or whatever the most frequently accessed data. If you want to maintain in a memory orientation, that is the thing. Now, if you are voting for the garbage collection, you have to miss out the magic of the caching ability. You have to limit at least, not miss out. You have to limit some of the aspects. Now, this garbage collection, of course, you may ask this question: what is the difference of Java garbage collector versus Spark garbage collector? Okay, let me give the standard thing. There is a concept called G1 garbage collector. Okay, and of course, which is an alternate. Okay, which is an alternate to use. There is one garbage collector name called default garbage collector. So G1 garbage collector is alternative to the default garbage collector. Now the point here is that what is the difference between G1 garbage collector and as well as the this default garbage collector? See, friends, a very important thing. Your G1, whenever the default parallel garbage collector divides heap into the static regions. So that means the default GC, okay, what it does is your default parallel GC divides heap is a dynamic memory, friends. Heap means dynamic memory, divides heap into a few static regions. Be with me, guys. Okay, default garbage collector divides your heap into the static regions. But whereas G1 GC, that means this is another alternative. No? For default GC, we got one more alternative that is the G1 garbage collector divides the heap into many small regions that are created. There is a difference, guys, dynamically. Okay. Whereas in case of the Java garbage collector, that is a default thread which is running automatically. But here there is an option called either you can go with the default GC or else by G1 GC. Okay, G1 garbage collector. If you want to perform the dynamic allocation compared with the default GC, then I can go ahead with the garbage collector 1 GC. You may ask this question, then what is the benefit of doing so? Okay, it is having certain advantages compared with the parallel GC, which improve the performance, particularly for Spark workloads that require high throughput and low latency. For high throughput and low latency, G1 GC is best compared with the parallel garbage collector. Now you have a look on this guys. What do you mean by this high throughput? Can someone help me? Throughput, response time, all these are nothing but the operating system things. So the number of jobs done by a particular engine in a second or in the unit of the time. Throughput is a turnover kind of thing. How many jobs I can execute? If I am expecting more number of the jobs to be completed in a stipulated time, then I can go with the high throughput. Low latency means, friends. Latency means
Like when we are doing some task that is happening quickly. So
quickly, without latency, without a waiting for a CPU context
yes,
switching, or just we are running our job and we are waiting for the result. That's all. There is no in between. Okay.
yes,
So for these kind of things, we need to have the applicability of G1 GC and as well as the parallel garbage collection. And of course, G1 GC is mainly dynamic allocation of these smaller jobs. And if you need any high throughput or low latency kind of the job, then better you go with the G1 GC kind of the garbage collection. Okay. So, like in this way, we can understand the Spark driver, cluster manager, and all these kind of the things. And as I said earlier, the client and cluster mode of the executions in the cluster mode, actually the driver runs on the worker nodes while the client node runs the driver on the client machine. Okay, so let me figure out that. Okay, so just if you are referencing the cluster mode of the operation, the cluster mode, the driver, Spark driver, runs on the, just it is running on the worker nodes because worker nodes are mandatory so as to execute the task. These worker nodes are executors while the in the client mode actually in the cluster mode we are getting these things while the in the client mode. Okay, while in the client mode runs the driver on the client machine actually. Wherever you are submitting your job, there only you are running. Of course, cluster mode is most powerful, guys, because either you can run your job uh, on top of this ARM or Mesos, all these kind of the things. And in client mode, and one question I am asking: suppose if I am asking you about the cluster manager, okay, whether in client mode or in cluster mode, where this cluster manager running on the single machine.
cluster mode.
Again, I am rephrasing the question. In which mode, whether in client mode or cluster mode, your cluster manager is running on the same machine?
In the cluster mode, it would be running on the same machine, but in the client mode, it can be in any machine.
Actually, in both the modes, both in client and cluster mode, the cluster manager is typically on a separate node. That is
Oh,
what, friends, we are losing our marks because though we are preparing, the problem is logically what we think in cluster mode, it is both cluster and Spark driver are running on the same machine. No, in both client mode and cluster mode, Your cluster manager is executing in the separate engine or separate node actually. Okay, so not on the same host on the driver. Okay, so let me give you this driver, like other than the driver, the cluster manager, other than the driver running machine, the cluster manager runs on separate machine. Like that, you remember. Somehow you need to observe this point, friends, because most of the times we are getting these kind of the questions, Spark driver and cluster manager, and as a developer also we need to have that distinction actually. Okay. Now, all the slots we can easily perform. Tasks run in parallel via the tasks. Slots is a part of an executor actually. That already we have seen. Execution can occupy multiple cores. Okay, because as we are always expecting the kind of parallelism, so obviously we can achieve that particular kind of the convention. Okay. Um, yeah, that's all, guys. Okay, with that, we can stop here. And in the meantime, just I'll be getting some more content for you. So definitely, which really helps you to understand how we are going and how we are performing the activities. Any doubts, please let me know.
Sure. Dr. Pawan, any suggestion like where we can practice these questions? Like, do we have any website available direct where we have the
Yeah,
practice questions available?
I'll do one thing. I'll share some blog actually. That blog really helped me to collect and compose this preparation also. I'll share some of the resources with you guys so that you can have a look on that. Okay, right?
Pawan sir,
Definitely. Yeah, Rizwan, how are you?
I'm fine, sir. How are you?
Oh, tell me. I'm fine, dear. Tell me.
Sir, do we have like some kind of sites or do we have that resource where we can get the old questions of the exams?
I'll share with you guys because we're having some three question papers actually. So though I'm teaching those things, but it is always better you also practice them. I'll share with
Yes,
you guys,
yes.
no problem. Okay, no? I'll share with
Okay, sir.
those three question papers and from the Databricks websites itself, we are having one question paper with us. So these four question papers, if you are practicing around 240 questions will be there. So we'll be getting at least 20 to 30% of the questions. So at least we can know that okay, in these lines they're asking the questions like that. You can practice. Hope that
Okay,
helps you.
no, sir, no, don't.
Okay, na? Okay.
Okay, okay,
Take care
sir.
then. Okay. All the best, guys. Thank you.
Thank you, sir.
Okay.
Thank you, Dr.
Yeah,
Pawan.
yeah. Bye, bye. I'll share those
Bye.
things with you. Thank you. Bye.
Okay, thank you.